done for like ever, and it says the wrong thing. I'm putting the wrong thing in, but I'm pretty sure I'm putting the
Then
right
come see me and I will help you.
Stupid.
All right. So today we are gonna talk about exponential functions and what an exponential function looks like. This is the first new type of function you have learned. You guys had learned linears in middle school. This is brand new material. Do you understand me?
Yeah.
But first we need to practice plugging stuff into our calculators. So everybody has a calculator. This calculator is very confusing, but other calculators are pretty easy to plug this in. Do you understand? Yeah. So using your calculator, type this whole entire expression in. So it's 3 parentheses 2 parentheses raised to the 4th. If you have the TI calculators, you'll literally type the button 3 parentheses 2 button parenthesis, and then there's a, why did I put a 3 there? Then there is a caret button, and you'll hit that, and then you'll type the number 4. So those of you that have this calculator will do it that way. Do you understand me?
Yes.
The others of you that have the Casios, who has a Casio? You guys have one that just has like an X to the box. So you'll do it with like a 3. There should still be a parenthesis button, right? And then there's an X to a box button on yours, right?
You put another
3. To
3.
the 4th. Gosh, I just love the number 3.
It gives you a parenthesis too.
So there you go. So Casios are a little bit easier for that.
You put another 3.
Never will I get this right. All right. So get that plugged in and tell me what you get. 2 to the 4th. 2 times. You never multiplied by 3, did you?
I did 3 times 2 parentheses.
So you need to go backwards. No, you don't. So you need to do 2 to the 4th. So do 2 to the 4th times 3. You don't have to even do parentheses. Do 2 equals, and then times the outside number of 3. Okay. So did you guys get 48? Yeah. Did anybody not get 48 and need me? Okay. Next one. Plug it into your calculators. Don't, guys, we just discussed this. You guys need to be focusing more. Plug that into your calculators. What do you get? It's
1.25.
That is 1.25. Who got an error? Raise your hand if you didn't get that so I can help you. If you did get, you should all be trying this. There should be no reason you're not trying it.
I got a question.
1 second. You probably use the subtraction button. You need to use the negative button.
Oh,
All right. 1 second. This.
It's about this problem.
Just 1 second. Just 1 second. Stop. Justin, then I'll answer your question. Anything to the negative power is a reciprocal. Do you guys know what a reciprocal is?
Yes.
So this is really 5 over 4 to the 1st. It's a reciprocal. It moves it down. And if you do 5 divided by 4 in your calculators, you're going to get 1.25, okay? That's why that happens that way. Riley, did you need something? Did you need something?
Fraction. I was told that it always has to be a fraction.
You should technically do a fraction, but since I'm not teaching the first day of the lesson because I'm not going to be here tomorrow, it's okay for now.
I was going to say the only one I couldn't find.
What?
Isn't anything to the 0 power 1?
Yes, go ahead and plug in the next one. Yeah.
This is not it's on the board. Oh, I didn't even know that. I thought 6 was 30.
Okay, guys, freeze. Stop talking. Plug the next one into your calculators and raise your hand when you got the answer, please. Okay, Brian, what did you get? 2.
Yeah, Brian.
Anything to the 0 power is? What do you guys think it is?
2.
Is 1. 2 times 1 is 2. So anything to the 0 power is 1. This is really like 2 times 1, which gives you 2. Okay. So with that being said, before you even try to plug this into your calculator, what do you think the answer is going to be here?
1.
Anything to the 0 power is 1. Check that. Do parentheses, 1 ABC 4, parentheses raised to the 0 power. So you can just do 1 ABC 4 raised to the 0 power. 1 ABC 4 raised to the 0 power. There you go. Did you guys get 1?
Yeah.
I got 25.
2 over 1, right, is 2. And then that's 1 because 3 times 0 power 1 is 0.
You're terrible at pomegranate.
I just explained it.
Stop for a second. So, because I'm not doing this with you guys and teaching you all the rules, I do want to explain to you guys why a negative exponent is a fraction, and I want to explain to you why anything to the 0 power is a fraction. So just listen for a second. You guys know that 2 to the 4th is 16, because that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. You guys know 2 to the 3rd is 8. 2 to the 2nd is 4, and 2 to the 1st is 2, because 2 times nothing. It's just listing 2 out once. If you take this, the base of our exponent is 2. Do you guys agree with that? If you divide those by 2, don't you get to the next number below it?
Yeah.
So what's 2 to the 0 power if you're looking at it that way? 1, because 2 divided by 2 is?
1.
So why is a negative exponent a reciprocal? Well, if you divide 1 by 2, isn't that a fraction? So that's where that comes from, if you guys are wondering why that's the case. So I wanted to make sure you guys aren't just getting gifts of that as well. We'll talk more about this second semester. Okay, let's just do a few more of these. So raise your hand if you've done number 5 already. Let me just think about it in my head real quick. Okay, what'd you get?
I got 1.
It is 1, because this would be 1/4. You flip this so that it becomes 2 squared, because anything to the negative power is a flip. 2 squared is?
2.
2 times 2 is?
4.
So that's 4 over 4, which is?
1.
But again, if you just plug it in from your calculator, that's where it comes from. Did you have a question?
Hey, Brian.
Oh, it's just 1.
So do you have to do 1/2 first?
Yeah, I got it.
You did get it? Okay. What did you, are you okay then?
Yeah.
There you go.
Okay. Close your mouth. Close your mouth. Stop talking. Do you have the next answer?
Well, actually, okay, I think I do.
What do you think it is?
Number 6, is it 1?
It is not 1. Be careful. Do 2 divided by and then 3 to the 0 power. What is it?
2.
It is 2. Did you get 2 this time, Colin, when you did it or no?
Oh, hang on a minute.
If you did not get 2, raise your hand so I can help you. Okay. Anything to the 0 power is? Anything to the 0 power is 1. So that's 2 divided by 1. So you're going to do 2. Divide it by 3 raised to the 0 equals.
Oh, I did 3.
Yeah. There you go. What's up?
I didn't get 2.
Yeah, it's because you made it a fraction instead of dividing it. That's a division sign, not a fraction. This here is a division sign. Okay?
So this is a fraction we divide.
Yes. Yeah.
Okay, so when you're doing something like this,
And then hit the division button.
oh, so it's dividing that
Yeah.
fraction.
Yeah, guys, don't use the fraction button. This note here is a division sign. This makes it a fraction, okay? So just be careful. I know that's kind of confusing. Okay, what did you guys get for number 7? Raise your hand. Yeah. What'd you get? It's a decimal of some sort. What'd you get?
1.
So this means that the 5 moves to the bottom, Tanari. Look at me, because you said, how did you get it, right? So this is 1 over 5 times 2. 5 times 2 is 10. 1 divided by 10 is 0.1. Okay? Okay, so what do you get for number 8? Yeah,
I think I have it. Is it 20?
it is 20. Because this goes up to the top, it reciprocates it, so that's 4 times 5, which is 20. Okay, so that's something you guys need to know is how to plug it into your calculator. Do you guys have any questions on plugging things into our calculator before we move on? Yeah.
I just plugged in number 8.
So you plug in 4, hit divided by 5,
Keep that in mind.
4 divided by 5, raised to the negative 1. So 1, and then your negative 1. Perfect. What's up?
How would you put that in the calculator?
Type in 4 divided by 5, raised to the negative 1.
Oh, okay.
Equals. What's up?
Oh, would you have to show me?
No, not for these ones, but you guys will, you won't have this worksheet until tomorrow in class. What's up?
So what's our homework tonight?
0. I got 10.
That's because you didn't put the negative 1 on the 5. You put it on the...
Yeah, I can.
Okay.
Did you see that? All right, no more talking. Shh. Focus. Focus. We're learning something completely brand new. Do we all know how to put things in our calculator now?
Yeah.
Okay, so let's get started here. So this is an exponential function. You will notice this looks different than our linear functions like y equals mx plus b or point slope form or standard form, right? This is an exponential function. You will notice the variable is the exponent. That is how you know something is exponential. The variable is the exponent. Instead of the exponent being 1, like in linears. So, A is the initial amount. You know how we have like y equals mx plus b, and b is our initial amount, and y equals mx plus b? In this case, the number in front is our initial amount. It's your starting point. B is your growth or decay factor, and we will be talking about growth and decay in just a second on the next slide. That is kind of like your slope. So growth and decay factors are kind of like your slope. Does everybody get that?
Yeah.
X is the exponent. In context, it typically means an amount of time. Is it minutes? Is it months? Is it years? It kind of depends on what the problem is. And then f of x, which is the same as y, is your total amount. Okay. So let's start talking about what exponential functions even look like. You know what the equation looks like now. So let's talk about what they look like and what the heck growth and decay even means, okay? Because that's important that you guys know because you guys have never seen this before. So if you're looking at the next slide, what do you guys notice about the shape of exponential functions? What do you guys notice about the shape? It's curved. It either curves upwards or it curves downwards. Does it go back up around though? Does it look like it's going to shoot back up? No, it does not. It starts low and goes high. It never comes back down, right? This one starts high and goes low and never goes back up, okay? This is exponential. We kind of say it looks like a J shape. Do you kind of see the J shape or the backwards J that's going on there? Why do you think the left one is growth and the right one is decay? Raise your hand. Why do you think the left is growth and the right is decay, Connor? Perfect. Growth means going upwards. Do you see how this J shape, do you see how this J shape is going upwards if you read it left to right like a book? Do you see how this one's going downwards? Okay, so that's what makes it growth and decay. So exponential growth means you look for the J shape to go up. For decay, you look for a backwards J that goes down. So the next thing it asks you to find is the growth factor or the decay factor. So when we're talking about slope-intercept form or any linear, the slope is always just the slope. In growth or decay, we have a growth factor or decay factor. What makes something exponential growth and what makes something exponential decay versus linear? We know that linear is a constant addition or subtraction. Do you guys understand that? Yeah. It's either you're adding the same number over and over again or you're subtracting the same number over and over again. To be exponential, you're looking for the same number to be multiplied over and over again. So you're going to look at your output-input table here. So do you see I can pull some numbers off of this table here? So I can say 0, 1, 1, 2, 2, 4, 3, 8. Do you guys see that I can pull those numbers from the graph? Yeah. Okay, so I put that in a table. As x increases by 1, what is happening to y? What do you guys notice is happening to the y? It's doubling, which means you're multiplying by 2. So you'll notice that we're not adding the same number every single time like a linear. Instead, it's going to be a constant multiplication. For something to be exponential, an exponential function, it has to have a constant multiplication. In this case, it's constantly multiplying by the number 2. So your growth factor is 2. This is a growth factor because it's a growth function. So if the number is between, or if the number is bigger than 1, it is growth. So if your growth factor or decay factor, so if your factor is bigger than 1, then it is growth. So look at that there and see what questions you have so far. Because there's a lot going on today. Okay, I'm going to make another table on this one and pull some points off of this. So I have negative 340, negative 220, negative 110, and then I have 0, 5. So those are the numbers I'm choosing there. Remember, it's a constant multiplication. So we're looking for that constant multiplication on the y. So as x increases by 1, what is happening with the y's? What are we multiplying by each time? You're not multiplying by negative 2, because if I did that, that would be negative 80. Jordan, you're multiplying by a half. Isn't the next number half of the one there? So what did some of you guys think about first?
Dividing.
You're dividing, right? You're dividing by 2 each time. But the problem is exponential is always multiplication. So what's another way of saying dividing by 2? Multiplying by 1 over that number. So it'd be multiplying by 1/2. So if you're thinking dividing by 4, that's the same thing as multiplying by 1/4. If you're thinking dividing by 20, that's the same thing as multiplying by 1/20. You see, you can think of it that way, but then switch it to multiplication in your head. So I'm not going to ever write it down as division, but we can always talk about it that way and then switch it to multiplication. Yes?
Would it have to be negative?
No, it should never be negative. Because if it was negative, it would switch signs. So your decay factor is 1/2. So if your number is between 0 and 1, then it is decay. So that is a lot that you guys just learned there. So take it all in. See what questions you have for me. If there are no questions after you've taken it all in, you can flip to the next page.
Just checking phone battery.
Oh, sure. Okay. All right, what about from an equation? So that's the next thing we're going to look at. How do we know it's exponential growth or decay from an equation? That's the next slide we are looking at. We've already kind of done a table, which will be the third slide, and then we're going to just talk about the graph of some of them. Okay, so how do we know it's exponential growth? In y equals ab to the x, b is bigger than 1. So if b is bigger than 1, we know it's growth. You must have a positive exponent to determine this. Okay, so we are looking for our base number to be bigger than 1. You know it's exponential because x is the variable, or x is the exponent. Because the variable is the exponent. Okay, so get that stuff written down, and then we'll look at each one of these equations here for exponential growth. So, exponential growth, in the equation y equals ab to the x, you're going to look at that b value. If that b value is bigger than 1, when the exponent is positive, you must make sure the exponent is positive first, then you know it's growth. You know it is exponential based on that exponent. You look at the exponent, and if it's a variable, you know it's exponential. We know it's linear when we have like y equals x plus 2 because x has no exponent on it, meaning it has an exponent of 1. So those are a little bit different. You can kind of see the differences there. So let's start with this one, Blaine. And y equals 1/2 times 5 to the x, what is your b value? Right, it's y equals ab to the x, so it's whatever has the exponent on it, which is 5. Is 5 bigger than 1? So 5 is greater than 1, that's why it is growth. Kaylee, what is my b value in the next one?
10/3.
10/3, is that bigger than 1?
Yes.
Yeah, that is 3 1/3, right? So 10/3 is bigger than 1, so that makes it growth. What is a little different on that third example there? What's a little bit different on that third example there? We have a what?
There's no A.
There's no A, that's true, but A doesn't really matter. It's kind of irrelevant here. A is technically 1, just like if we have y equals x plus 2, there's a 1 in front of the x, right? Yeah.
That's a decimal and it could just be 1/4.
So that should be y equals 1/4. What else did I just draw an arrow to? What do we know? Can we have a negative exponent? No. What did I tell you guys at the beginning of class really quickly about negative exponents? It's a reciprocal. So really, this is y equals 4 to the positive x. Now is this growth?
Yes.
So once the exponent is positive, you can determine growth or decay. So your b value is just your growth factor. Our growth factor, our b value, b represents the growth and decay factor, is just the base of the exponent. So when we talk about growth factors or decay factors, we use the letter b. Just like when we talk about slope, we use the letter m. For growth and decay factors, we use the letter b. Connor?
On the homework tonight, do we have to do all that?
No, you could literally just say grow. Oh, well, it depends on what it asks. It tells you on the homework you're going to determine linear or exponential. If it's linear, you have to tell me the slope, and if it's exponential, you have to tell me the growth or decay factor. If it's neither, you don't have to do anything, okay? Okay, what makes something exponential decay? When exponent is positive, b is between 0 and 1. So Tari, in y equals 2 times 0.5 to the x, what is my b value? And 0.5 is between 0 and 1, right? If you were to count it, so that makes it decay. Grace, what's my b value in that next one there? 2/3, which is between 0 and 1, right? How do we need to rewrite that last one before we can say anything? Because it has a negative exponent. Riley?
You gotta make it 1.5.
Yeah, it's 1/2, and that makes it positive. So what is our b value then, Riley? 1/2, which is between 0 and 1,
Yes.
which makes that decay. All right, so before we move on, take this slide in. Do you understand how to determine that it's exponential and how to determine it's either exponential growth or decay when given an equation? So if it's a negative exponent, all you do is flip it, and that makes the exponent positive. So this is like 2/1, so we flipped it to 1/2, okay? Other questions? All right, how about from a table? We kind of already did this one because we rewrote our graphs as tables. So, exponential growth from a table. As x goes up by 1, you multiply by a number greater than 1. That's how you know it's exponential growth. You're multiplying by a number bigger than 1. So Justin, what did you just say you're multiplying by? You are multiplying by 4 each time, which means your decay or your growth factor is, what's our growth factor, guys?
4.
So we know this is exponential. We know this is exponential because it's a constant multiplication of the same number. We know something's linear because we constantly add or subtract the same number, right? Do you see the differences there? So for decay, as x increases, by 1, you multiply by a number between 0 and 1. So you can think about it as division first, but you should never ever tell me you're dividing by a number. You should always write that as a fraction. So you can think of that as division first. So Justin, what are you multiplying by each time? Yeah, so you can see it as, in your head, you can think, oh, I'm dividing by 5, which is the same thing as multiplying by. So this is a decay factor because it is going down by 1/5. And remember, that's the same thing as b. All right, before we do some graphing, before we do a little bit of graphing, which we will continue on the block day, ask all the questions you need about growth, decay, and exponentials. Connor.
Can you go back a slide?
Back a slide, yes. And then I'll go back forward again. Again, I will not be here tomorrow, so you guys will work on your worksheet you're getting today, plus a worksheet I'm giving you tomorrow, plus a clever assignments if you're done. Does everybody understand that? Let me know when you're ready, Connor. What? Yes. So you're going to go next door. I need to write a note in my sub-plans. Are you good? Brian, do you need this one? Okay, everybody else should be on the back page with their calculators out. Calculators should be out. We're going to learn how to graph these things.
I love it.
You good? Okay. So, in your calculators, we're just using the values -2, -1, 0, 1, and 2 to graph this. So, you're replacing the x value with that number. So, in your calculators, do 2 times 3 to the -2nd. That's why we practiced this at the beginning of class. So, type that in and tell me what you get.
Yeah.
Yeah.
0.074.
You should get 0.2 to repeat it.
Oopsie poopsies. I didn't get it.
You should be doing -2, not -3. Anybody not get that and need my help to check what you did wrong? You did -7, not -2. That's a -2. Anybody else? Okay, do the next one. Did you get it right this time? I get that you could write these as a fraction, but we're going to go with this here. So what would you get here?
0.666667.
Which is the same thing as 2/3? This is the same thing as 2/9, by the way. Okay, plug the next one in. There's a 0 there. Do you see how there's a 0 right here? Do you guys understand where I'm getting these numbers to plug in for x?
Yeah, I understand.
Do you understand what equation I'm using?
I understand.
Do we all see those pieces that I'm using there? Because it's important, obviously, to know where all these numbers are coming from. So what is that?
Someone kill me.
How about 2 times 3 to the first?
6.
And then how about 2 times 3 to the second?
18.
So do you guys notice the ordered pairs that are there?
Yeah.
-2, comma, 0.2, repeat it. -1, comma, 0.6, repeat it. 0, comma, 2. 1, comma, 6, and 2, comma, 18. Go ahead and plot those points. You're going to have to do your best guesstimate for some of those.
Fly the plane and
Okay, you should have a graph that looks like this when you are done. You should not cross the x-axis. We will talk about what is called an asymptote on the block day. That's the word I just used. You're right, asymptote. Okay, if you did not get that table right, let me know now so I can come and help you for a second.
I'm just confused how you got
Got where? I'm just guessed. So, you mean for negative 2.22? Is that what you're saying, or are you talking about these points?
all of them.
Did you plug these in by yourself or no?
Yeah, I did.
So you got 2 times 3 to the negative second. Do you see the 0.67 there?
Yeah.
Did you plug in the 2 to the 0 power by yourself?
No.
So I just kept plugging things in.
Okay.
And then I plugged in 1 for x. And then I plugged in 2 for x.
So then you put the expo. Oh.
Do you see it now?
Yeah, but then how do you graph?
Okay, so that's negative 2 comma 0.22. So negative 2 is here, 0.22 is less than half, so I just made a point less than half. Do you see what I'm saying?
Yeah.
And then negative 1.67 is a little more than half, so I did negative 1 comma a little bit more than halfway to 1. It's like 2/3. Do you see that?
Like right here.
I don't know, put a pointer, I can't see it. Looks beautiful. Then I did 0 comma 2, 0 comma 2.
Oh,
Okay.
so these?
Those are your x1. Okay, anybody else confused with this graphing? Because these are good questions I'm getting asked.
Can you re-explain what you told George? I don't know how you got
Yeah. Do you understand how I got all these numbers?
Yeah.
Okay, so this is your order pair, x comma y.
Oh.
X comma y.
Okay.
Do you see those now?
Yeah.
So negative 2 comma 0.22 is where on this graph? It's a little less than halfway, so perfect. So put a point there. And then you do negative 1.67. Yep, and then you do 0 comma. Do you see it now?
Yeah.
Anybody else confused by these points? Go ahead and do that next one on your own. Come on. Try that next one. Yes, guys, you should be trying the next one. See what you get when you plug that in. Make sure you plot the points when you are done. Connect it with that J shape. You are not making the graphs. Did you get 27 for Y?
Yeah. 27.
Good.
I don't understand why we have to graph everything.
So you can see what it looks like. Then I got 9. Are people getting those numbers? Or is anybody not getting those numbers or have zero clue where these numbers are even coming from? Those of you that have asked questions, because you're confused, thank you. You are helping yourselves. Those of you that are sitting there confused, not asking anything, you're not helping yourself at all.
How are you supposed to graph it?
That was nice. We'll talk more about that tomorrow. Yes, there is. Well, there isn't no negative y value, so it doesn't matter. You will never get a negative y value with this, so it doesn't matter. We'll talk more about that on Wednesday.
What?
Okay, so that's what I got. Did you do this on your own, or did you just copy what I wrote?
No, I had it at first, but I had the negative, so.
Okay, plug it back into your calculator so I can see.
27.
So you're good, and then raise it to the negative second.
Okay.
Negative 2 equals. There you go.
Okay, I might have accidentally put like negative.
Yeah, you might have multiplied by negative 2. Yeah.
I got a fraction. Oh, okay, you got it back as well. Never mind.
Yeah, 1/3. This would also be 0.3. Repeat it. What's up, guys? What's up? What do you need? What do you need?
What up, B?
27's not on your graph, so don't graph the first point.
So wait.
Start plotting your points.
Never mind, I got it.
Are you sure?
Yeah.
So your J shape is this way. Okay, get your graphs graphed, please.
What if like 1/3 be like right there?
But it's 2 comma 1/3, so it'd be like it's like if you were to split this square into 3 pieces evenly.
2 comma 1/3, so like right.
I'll check it. Perfectly fine, but it would be on the line because it's 2 comma number. Do you see that?
Yeah.
Okay, guys, I need everybody to stop talking.